This experimental appliance sends out electrons against the light screen. There they are visible as a green spot. On the bottom on the right side you can see the voltage with which the electrons are being sent. The higher this voltage is, the more electrons are being sent. If the voltage is low, a spot is visible. You expect that if you think of electrons as particles. If you otherwise turn the voltage higher, you can see rings. Why are these rings there? To prove that electrons are shot, you can divert the stream with a magnet. The spot moves. To understand the cause of this experiment, we're using following analogy. To show the behavior of particles, solid balls are shot at a wall. In this wall there is a slit and behind it a light screen. If the particles are shot against the wall, an increasing number of particles occur on the light screen where the slit in the wall is. The same happens if you shift the slit. If there are now two slits in the wall, the ball will increase at both places. The waves are behaving like the particles. Similar to the experiment with the balls, we try the same with the waves. When the waves arrive at the wall, there's also an increasing number on that spot. If you shift the slit, the increasing number shifts. Something different happens if you have two slits at a time in the wall. The two increasing numbers don't occur. Instead, there's a strange increasing number of the waves along the wall. The waves are distracted at the slit and get after that to the back wall. If now the waves are distracted at two places, the waves eclipse themselves. Interference is built. Positive interference means that a wave crest meets another wave crest, or a wave trough meets another wave trough. The wave gets stronger. Negative interference means that a wave trough meets a wave crest. The two waves erase each other. Now we're using electrons instead of particles. As expected, the electrons are behaving in the first two experiments like the particles. The surprising thing is that they are acting like waves as soon as you shoot them against two slits. That means that electrons are waves too. This is what we call the wave-particle dualism of electrons. You can explain the qualities of the electron shell through the wave character of the particles. The shells of the electron shell show the positive interference, everything in between the negative. The electrons who are probability waves only show in case of positive interference, because only then the probability is big enough. Therefore there are shells in the electron shell with given distances, because positive interference only shows at an integral voltage. In that case, electrons can't fall into the core, because there are only negative interferences and therefore there isn't a source of realization.